We're going to take a look at number 1. We're going to use the Pythagorean theorem to find our hypotenuse. So our formula is a squared plus b squared equals c squared. So we're going to have 10 squared plus 24 squared equals c squared. And I know which one is c squared because this is our hypotenuse over here. Then we have 10 for this leg and 24 for this leg. So 10 squared is 100 plus 24 squared, which is 576, equals c squared. So then we add 100 and 576 and we get 676 equals c squared. Then we want to take the square root of each side, which then gives us 26 equals c. So our hypotenuse would be 26. In 4, we're going to write our formula again. A squared plus b squared equals c squared. And we're going to plug in our numbers. So we have 11 squared plus b squared equals 23 squared. 11 squared is 121 plus b squared equals 529. Then we're going to subtract 121 from each side, and we get b squared equals 408. Then we're going to take the square root of each side, and I get b equals 20.199, and I'm going to round it to the nearest hundred, so I get 20.20. For number 7, 8, and 9, we're going to use the distance formula. And the distance formula is x2 minus x1 squared plus y2 minus y1 squared. In class, you learned that you could also write it x1 minus x2 squared plus y1 minus y2 squared, as long as y1 was first on each, or x2 and y2 were first on each. We're starting with our first two coordinates, which are -2, 4, and 3, -1. We have x1 and y1, x2 and y2. Then we're going to plug them into our formula above. So we have 3 minus -2 squared plus -1 minus 4 squared. So then we're going to combine. So I have 3 plus 2 squared plus -1 plus -4 squared, which gives me 5 squared plus -5 squared. Then I get 5 squared, which is 25, plus -5 squared is also 25. And I get the square root of 50. And the direction says to round your answer to the nearest tenth. So this equals 7.07, and we're going to round that to 7.1.